Okay, well now let's actually have a look at a question to do with simple harmonic motion. I've kept it simple. We've got low tide. The water's 8 meters deep at 7 a.m. and we've got high tide. The water is 12 meters deep at 1 p.m. So from low tide to high tide is 6 hours. Now that might not be reality, but let's just go with that for this question. T is going to represent the time from when we had low tide, because we've got to chime in at some point. We could chime in mid-tide or at high tide or low tide or whatever. So we're going to, in our equation, set up an equation describing this situation where T is the time from 7 o'clock in the morning at low tide. And then we can use it to answer something like when will it first be, when will the tide first be at 11 meters deep or something like that. But let's just set up the equation. So I'm going to write down your stock standard equation for simple harmonic motion, because that's how the tides are working. They're in a cyclical thing, so it's going to be simple harmonic motion. You've got your x equals a cos nt plus alpha plus c. Now, if it was oscillating about the floor of the ocean, so it goes down negative and it comes up positive, well, the center of motion would be at 0, but it's not. The center of motion's somewhere up in the water, such that the water goes up to 12 meters and down to 8 meters, up to 12, down to 8, up to 12, down to 8. So if that's happening, if it's at the top, it's up at 12, and at the bottom, it's down at 8, the center of the motion is clearly at 10. So our plus C will be 10. So I'm going to pop that in there. That's a pretty easy thing to see straight on up. Our plus C is plus 10. All right. Also, the amplitude of our oscillation is easy to see. I just erased that off, so I'll just draw that back up. But if we're at 10 and we're going up to 12 and down to 8, we're going up 2 and down 2. So from the center, up and down, we're going up and down 2. So the amplitude of the wave is 2. So that's going to go here. X is equal to 2 cos. And now we've just got to work out what n and alpha is, and we've got our standard equation set up here. Now, if we assume that when it goes from low tide to high tide, it takes 6 hours, so it takes 6 hours to get back to the next low tide, the big assumption that we're going to have to from this question, the period of the motion, the period of the oscillation, going from low up and back to low again, one full cycle, is 12 hours. Now, we know from our work in previous times that the period, T, the period, is 2 pi on n, where n is that number in front of the angle. We know that. So the period is 2 pi on n. 12 hours is 2 pi on n. So therefore, if you rearrange that, n is equal to pi on 6. N is equal to pi on 6. So I can pop that in here. So I've nearly filled out the whole of my equation. I just need the plus alpha. So how am I going to work that out? Well, I know at the very start, T is the time from low tide, and low tide, it was at 8 meters at 7 a.m. It was at 8 meters at 7 a.m. So I can actually pop in the fact that it was at 8 meters at time is 0, because T is the time from low tide. Well, we're at low tide, so time is 0. So I can actually pop those numbers in, 8 meters, and then work out. So minus 10 off both sides. Minus 1 equals cos alpha. So alpha Cos of what equals minus 1? Cos of pi. So alpha is pi. So just by substituting in those values, I was able to work that out. Now, I can clean this equation up a little bit because I know in the third quadrant, this is the pi plus quadrant. I know if you go around to the third quadrant, cos of anything in the third quadrant is the negative of cos of the basic angle in the first quadrant. Like, for example, cos of 240 degrees, that's pi plus 60, is the negative of cos 60. Cos of pi plus pi on 6 is equal to the negative of cos pi on 6. Cos of pi plus pi on 6t is equal to the negative of cos pi on 6t. So I can clean that up and just say this is equal to the negative pi on 6t plus 10. So I can get myself an equation from the information in the question, and then I can answer all sorts of things about it. At 11 o'clock, like 11 a.m., how deep was the water? So how long from low tide is 11 a.m.? 4 hours. So I just need to put a 4 in here for t, work it out, it tells you how deep the water is. Be careful sometimes because there's going to be a number of possible times where the water will be 11 metres because this thing goes up and down and up and down and up and down and up and down. So it'll be 11 metres at various times of the over a few days, if you like. So you need to sometimes read questions carefully and see whether it wants the first time that it's a certain depth or the first time after, the evening that it's a certain depth. So you know which value you need to actually find. But that's for a later question. Today's video was just setting up an equation from a question to do with simple harmonic motion.